Try that command out too on the RGB, and let's see if we can make the RGBs do their thing. And one of them not supposed to hit return either. I think it's just like QR.
We should connect. Okay, so QR.
Colon. And now try it. See, where's channel 1? It might be on the wrong channel.
I think you're wrong.
Okay, try again. That should work. Okay. QR colon, are you doing that?
Yeah.
Oh, go the other way. Looks like you're too far. There we go. Yeah, that's what I'm talking about. And the space bar is the one that changes colors. That's such fun.
Remove this one. Like, is that my beer? Or
That's your beers.
so that will be the terminal window up, like it's going straight up and down. Or we should move this one out of the way. Dude, it's all tangled.
Dude, what can I say? Been busy. Let me get these daughter boards to work.
Take this out of the way. So hey Dave.
Hey Aaron.
Why don't you show everybody some cool stuff that our bootloader does?
Absolutely.
Okay, so we're going to be showing like some overhead shots here of like the fast hardware setup on a little test panel we have here. So like I'll just show real quick that. So this is like coming into our system. There's our high voltage supply, which we're really not taking advantage of right now, and the 5 and 12 volt supply going down through our fast filter board that has all the fuse protection and everything, down through this cable and then into our system, which is our nano controller here set up, and then this whole network of the 1616s, a couple 3208s, and a whole bunch of 0804s. And these are just set up as like kind of a test bed so that like Dave, who's been working on all the bootloader code and stuff like that, has a nice consistent like hardware interface to mess with. So so yeah, I don't know, where should we start with this?
Well, probably starting about a little bit of the goals. It's like, it was amazing to go back and find out when we actually started this project. This was started in, I believe it was July 14th. Isn't that what we pulled up?
Yeah.
So this has been going on since July, and it's like, it was just, I kept trying to have versions. Actually, it kept getting better and better, and it's like, I kept having a whole bunch of different bootloader files. There were separate ones for the 3208 and separate ones for the 1616, and I was trying to make something that we could distribute just one file and have it work for every single controller. And with every single I/O driver having a controller, and then the nano board having multiple on there, it gets pretty complicated on how to distribute all the software. But anyway, I was able to make one text file that you simply send over via a terminal emulator, and each processor gets its portion of the code out of this one single file.
One thing we should probably say too, like what we're describing right now is the firmware that actually runs on the hardware itself. So when you're using a pinball framework or writing your own code, you're actually talking to our fast pin protocol, and that's what's actually running on the physical hardware itself. and this handles all the like the controlling the drivers or the reading of the switches, all that kind of stuff. And the kinds of updates we'd be doing to that won't be as frequent as you might be doing to your game software or something, but the process of actually maintaining the proper firmware revisions and things like that on the hardware itself is what we're describing. So yeah, just want to clear that up.
So kind of some features, like for instance, 1.0 is what we're calling this first release, and it's been pretty thoroughly tested. Right now I'm working on what I'm calling 1.1, and the big thing that's going to include is the daughter boards. I'm starting to write drivers for the 16. In fact, I don't know if we have some of those laying around. I have them somewhere. We'll keep looking.
So here's a matrix one.
But yeah, here's a board right here that does 64 switches, and then we have another one that does 16 switches. So on any of our I/O boards,
matrix switches.
Matrix switches, and this is just 16 individual switches. So whenever I get 1.1 released, you should be able to put either of these boards on any of the I/O boards, and they'll recognize those extra 16 switches or 64 switches. And
just showing, see how the daughter boards fit. Like here's one of our 3208 boards, and any of the daughter boards just actually seat onto these couple headers here, and they'll pass the 16 switches through, which gives that stable connection, but you don't lose the 8 switches there. And then in this case, this is the servo controller, and it gives you control for 6 individual servo motor controllers. There you go.
So I guess maybe what we can do is just pull up a terminal emulator window and see what the current version is, and maybe try to. I think right now we're running at 0.99, are we not?
Yeah. So let's see. Let's switch over to that. Okay. So which one are we?
That's
on the net. Okay. So right now we're connected to the RGB processor. So let's switch over to the network processor. So our controllers have multiple processors on them, and each has a dedicated task. So in this case, we're connecting to the network processor. So what I'm doing is I'm entering the IDE command, and entering IDE to whatever processor you're connected to is going to return back which processor. In this case, the net one. It'll tell you it's the board ID of that processor. This is the O2, which is the nano controller, and then the firmware version that's running on it. So we reverted it back to 0.99, so we can have an effective process of showing an update and actually see it actually do something.
And I guess what we can show too is let's do
you want to show some of the commands and stuff like that.
Yeah, let's do the CN command. Okay. And what this will do is show the configuration of the network. So what the Nano's done at this point in time, the Nano controller has gone out and in order has talked to each one of the individual driver boards that's connected to it. And the very first one is the one connected to the out of the Nano controller. So the first 1616 board is there, then that's connected to the 3208, and you can kind of see the list going on there. You have a couple 3208s and then a lot 0804s. And right now you can see all the version of those as well as that version 0.99. So anyway, what we can do now is we're going to open up this text file and send this text file over, which is going to contain everything. This contains a new RGB controller code, it contains new Nano controller code, and all of the individual pieces of code for each one of the I/O driver boards.
And so what I'm doing actually that you can't see on the screen is I'm going to this text file that contains all the code that's updating, and I'm using the terminal emulator send text file command. So I'm about to do that, and I'm starting now.
So what just happened there is that the code is now running. You can kind of see that copy complete, verifying the application.
Should we scroll back through and look at the commands kind of step by step here?
That'd be a good idea. We're going to probably scroll up the screen again, but you can kind of see the bootloader initiated. That's kind of the code portion. So
basically, here's the big block of code that got pasted in, and then there we go. So then the bootloader starts in.
And what's happening now is behind the scenes is erasing all the parts and erasing each one of the controller boards, which you should probably, I guess we can go back again if we miss all that. But you can kind of see that it extracted all the information. All those dots on there are all the pages being programmed into the part. And then at the end, you kind of see that it was successful. And then anyway, scroll all the way down to the bottom and we'll see what happens. When it says restarting, there are some new commands now. That exclamation B is kind of like an informative message saying the bootloader is restarted. The exclamation point BO2 is saying that it's launching the application. And these exclamation S's are saying that it's a system, interrupt, basically saying that it found some code out on the network boards that's not the right version. So there's going to be a new message for each one of the I/O boards it finds, and it's sending data to those. Where's it at in the process right now? Is it okay? It looks like I think we might have messed something up while we were doing commands while it was still running. Let me do this again. So it only updated 2 of the boards, so I think we interrupted the process by what we were doing.
Scroll through. Okay,
So
let's send it again. And I won't move the window around.
the main controller has it. I think what's going on at this point is that we just stopped the process from doing whatever controller was out there, so we might have to use our new command we're going to get to in a second called the BN:AA55 command. So let's see where it's at. Let's see, we are still over here again. Okay, let me try this. BN:AA55. Found definitely one of them that wasn't programmed correctly in there. Why don't you update the RGB one for a second and let me go back to this. So kind of just put 1.0 back into the RGB controller and then reset this one for a second. Let me, we will not interrupt it next time.
So I'm connected to the net or the RGB processor that we saw right there. So should you go ahead and send that?
Yeah, so go ahead and send that same file, the 1.0 file, to it.
Okay.
So maybe do the QN command in there and then
QR.
our QR command. We can kind of watch that all being done, and you did the ID on there.
So right now we're just running one of the query commands that we set up for the RGB processor. And one of the things that, like, when you're wiring up all your hardware and you've got all your LEDs wired, and your switches wired, and coils wired and all that stuff, we set up a command on the drivers that you could go through and just step through, and it sends like a small safe pulse value at each thing. So you can say like, number 1, or first item, 00, where are you at? And it might pulse some driver and you recognize, okay, that's my slingshot, and then you scroll to the next one. So what we added to the RGB processor was the ability to do the same thing. So we're just going to step through these, as you can see here, and that moving down the band. And what's showing in the terminal window is, right now I'm showing you 0A, 0B, 0C. And then, oh wait, I can scroll back. And right now I'm just pushing the Q and W characters and moving through. Now on any of them that you're on, pressing the space bar will cycle through RGB. So again, you can, if you think like one of the LEDs might not be working on your individual RGB LED, well, that would be a way to kind of check that out. So again, kind of moving up and down. Look at that! Watch out, David's getting to your hand.
I got out of the way just in time. So let's go back one more time to the network controller. And let me try to restart. And this is a new command too. A lot of people requested a new way to, reset everything back from the beginning. How do I do this? Just click right here.
Yes.
So a way to call a bootloader all by itself, which will also do a system reset, is you just say BL:AA55, and what that does is start the bootloader, but we've given it no instructions. So that starts, the system back up again. And So there we've got this node is talking. So right now I just put one in the loop. Let me see what version that's at. Okay, I've got one in there. It says this is version 1.0. So let me try getting two of them in the loop. It's unfortunate it's a little hard to do all these cables right now. Okay, let me come in here one more time. Okay, it looks like it's down here trying. That's what it's doing right now. You know what? It may have been doing this the whole time and we just didn't see it doing it. I wonder if we were covered up. Yeah, we almost should. Let's get that other camera going so we can actually see this.
The progress. So right now we're at this node right here. And you can tell by the movement of the LEDs. And now we move down to here. So we're moving through the network chain. So you can kind of tell, like from a progress standpoint, like where things are currently happening. So that one, when it's finished programming itself, pop up this one here.
Or maybe zoom on those two. That's perfect. Just stay right there, and so we can see that when this one finishes, go up a little bit higher. There we go. And now we'll see the other one start up here in just a second. So now it's starting. So we just have one more left after this, and that should have programmed all of them with the latest code. And we'll see in just a second by doing another CN command.
There's the last one. Doing its cool Knight Rider effect.
Okay, and hey, it looks like the whole network is now back alive.
Everybody's all happy. So let's go back to here. Okay.
And now if we do that CN command one more time, I guess I have to click on this window.
Yep.
And now we can kind of see everything is now, which it was at version 0.99, it's now at version 1.0. So it looks like everything updated successfully. So anyway, there's some pretty neat features that we put in there just in case things do go wrong. You've probably seen all the time, like if you're reflashing the BIOS in your PC, like never turn off the power. So you know, pinball machines, you know, there might be something going wrong, short something out, we're down there screwing around, something may happen, but so there's a few methods that we have to completely erase the applications off should anything ever happen. There's a couple wires you can short on the debug header that will blow away the entire application in any of the processors, and then you can rerun the bootloader and that'll work. And then there's also another method if just one particular mode or node out on the I/O boards does not have software in it. You can do a manual update on that one as well by just doing a bn command, bootloader network, and it will rerun the bootloader across the network, and any nodes that aren't responding should then see that and start responding to it. So in a nutshell, that's kind of you know what we got going on.
What else do we want to show? What other cool things can we do?
Let's see.
So on the terminal, like you know, we cruise through real quick, like what's showing on the node definition there. So we ran the CN command, which is the configured nodes, and that's going to list out all the nodes in the system, and kind of running from left to right. You know, you got the name of it with, you know, the fast I/O 1616, version number, how many switches it has, how many drivers and hex, and then the node serial number and things. And while these are, you know, just nice to see when you're checking, you know, firmware commands and stuff like that, but for people writing a software framework, they can, you know, their software framework can send these same commands. So say, for example, like we expose like a web service that broadcasts the latest firmware versions for each different piece of hardware that we have. You know, someone writing software could query that and see like, oh, if 1616 is being run, it should be running version 1.01 of the firmware. And if they know that a feature in their framework depended on a feature that may have been introduced in that new firmware, they could work into their, you know, startup of their code to say, hey, I see you have a 1616, and I see you're trying to call this command. You need to update your firmware on this. So we really tried to make sure that like the commands and stuff we made available in the hardware weren't just useful for people, you know, just tinkering directly with it, but actually some stuff that people would actually use. Hey, Dave Space. Actually use to make their software and the frameworks and stuff like that more effective. And I think that that's where our goal for what actually runs in the hardware itself is to make as much of the software programming interface against what we have, make it as elegant as possible. And that's really why we spent the most time actually like dialing in this firmware, making sure we have a good healthy bootloader that can maintain all that so that those updates are done safely out in the wild. Um, yeah, I don't know. I think it's kind of cool.
I guess we can talk about a few things too that are kind of coming up, or what
Yeah, go for it.
some of the goals are. So one thing was about the daughter boards and how and what I'm thinking on doing is right now when you do that CN command and it pings all the individual nodes, if a node does have a bootloader attached to it, or kind of bootloader, if it does have a daughter board attached to it, what I'd like to do is actually put it underneath the node, so it will kind of show you the node, like this is node 0, it has a daughter board, the daughter board happens to be a servo, and then it will kind of show you what the servo needs, like how many pieces of data. So looking at the screen, can we go back to that a little bit? That's one. Looking at this output, I don't know, if you've seen this before, but after the version, it kind of shows switches, drivers, XI and XO. So what that does is it's kind of showing you how many switches each node has, how many drivers it has. The XI is how many extra pieces of data input and how many extra pieces of data output. So the servo board, for instance, even though it's not returning anything right now, it has 6 bytes of output, and it's been hard coded to work with the servo board right now. So the servo board can work with any I/O node board. But anyway, there's 6 servos, so 1 byte of data per servo, and that's kind of what that means. So as soon as I come out with the next version, everything should be XI and XO will be zeros unless you put a daughter board on, and then whatever the daughter board needs you will see there. And same thing with the switches. If we have like an 0804 and you put in an additional 16 switches on a daughter board, you'll now see 14 hex switches for that particular 0804 board. But anyway, so this list will get bigger as you put daughter boards on there, and let's see what else.
And that's one of the things too with the daughter boards. Like we wanted to make sure that, like when we were first starting to make the hardware, a lot of the feedback we got from people was, don't tell me what I need to use to write code against this, or what CPU I need to use, or what part I need to program up to. So we made that pretty wide open. Just anything that can make a serial connection to our hardware, like you're good to go. And the other thing was people want to be able to make modifications and toys and things like that. And I think that's the thing that more than anything, hey, Dave Space, we want to do with the daughter board interface. And so that daughter board interface is something, one of the things we'll be working on here before long is getting like a prototype interface that basically lets people start to kind of tinker with and make their own toy pieces to plug into this. Because I think there's a lot of people that have done some pretty cool things with Teensies and Arduinos and things like that, and we want to make sure that like adding in different mods and cool pieces that people make elsewhere, they can actually put that into the pinball system and have that come to life. And I think that's going to be cool to see, and it's very like Dave was saying, it's designed to be simple to work with in and out. So we can have the spec and the footprint basically for what it's like to interface with the boards themselves, what pins bring you power and things like that. But I think it'll start to be pretty cool when you start seeing people creating new ideas and new concepts, like putting in new sensors that, the price finally came down low enough on some certain sensor that somebody's been dying to play with, and they want to somehow work like, I don't know, like a barometer into their pinball machine for some reason, or like, who knows. I think it'll just be really fun to see people from different disciplines and different experiences, like maybe pull something from their day job they're working on that's really cool that they thought would be cool in pinball. We want to make sure that it was really easy to bring in fun, new, innovative little things. And the daughter board interface will be a good way to do that. I don't know, what else are we going to talk about? So I think why we're kind of being awkward and silly on this is like this bootloader thing was such a big deal for us that like, it's been so much work for us to make it so that we can update that safely and have it, so we do code updates in the wild and things, and I think that it was such a major milestone for us that like we want to celebrate something, but it's in the category of like something I would like tell my wife about, and she'd be like, oh, that sounds nice. And it's like, oh, you don't get it, like this is such a big deal. So I think that we want to just kind of throw this out here, and if anything for us, just kind of mark this moment in time and be able to say like going forward now we can get back to focusing like hot and heavy on hardware, and know that we have the software infrastructure to support the new features and new innovative little interfaces and stuff like that we want to provide. and let people get back to just focusing on making great games, and know that we're excited about bringing new things in and lighten their or create a better experience for them in their game building process. So.
And it is great being back on hardware again. I got to say, I mean, right after the bootloader was done, and it's probably about a little over a week right now.
Yeah.
So I already start working on one more daughter board, and got that already. It's the board's out for production right now. So God, it feels good to be back on hardware again.
The fun part, it's like getting your chores done and then get back to the part that you enjoy. But it's I don't know. It's just that's one of those things that Dave pulled up the document spec that we'd come up with back in back in July, and to go down through it, and there were things in there that I think you'd even forgotten that were in the list that seemed like they came up later, but it was all already in there, and to see how thoroughly we were able to work through that list, and it wasn't something that was rush, hurry, get this out so we can say it's done. It was, Dave had a vision for what that needed to be, and taking the time to go through and do it right. I don't know. I thought that was pretty rad to pull that list up too.
It was because it was kind of part of it was a dream list. If we had the perfect,
this would be ideal.
What would it be like? And the biggest thing that I always cringed on that list was trying to make one code that runs everything, because there's so many pieces of code in that one file. So man, once that was actually working and see that it was a wish on the original list, and that actually start working, oh man, that was exciting times.
Yeah. So okay, I just noticed we got some questions and stuff. Let's see. Love the polyfuses. Polyfuses are awesome. Those are those green fuses that you see on some of these things. Where are they at there? We have them on the servo boards, and
probably
let me grab one of those real quick.
Yeah, we actually do have one on just about every board. The filter board doesn't have any, as far as I know, but it's every daughter board and nano board.
Yeah, so that's what. Whoops. There we go. Here. Where's the camera? Yes. So that's what gave. Too many windows going on. Okay. Stop moving. There we go. We got some delay here. Okay, so those are those three green device or pieces there on the play field, and those are polyfuses. Dave, explain polyfuses.
So a polyfuse is like a self-healing fuse. So what happens is when there's a bad thing about polyfuses is that a normal fuse, when you get above, if it's a 4-amp fuse, you don't have to be too far above it. It kind of at 5 amps, it's going to blow pretty quick. A polyfuse has to sit there and get hot. So it's based on what the starting temperature is versus how hot it gets being under short. So if you short one out, it is almost infinite current for a very short point of time, but it does open up and it keeps just enough current flowing through it to keep it in this high impedance state, so it's removing most of the current from the load. But the beautiful thing is that they are self-healing. So once the short's removed, it cools down. It's it kind of resets itself. So they are wonderful devices. It's can do stupid things and it doesn't burn everything up. So
yeah, I think they're pretty cool. Let's see, what else we got here? Gabe says this is awesome. That is awesome. Mike's late. Mike, you've heard all this stuff before already. This is us just kind of geeking out on stuff. Oh, we could show. Show this out. Hold on. Behind us here, is kind of my attempt to start to have inventory, but having tons of boards and stuff now. These are a whole bunch of
all the I guess
it's this one?
filter boards. Filter boards.
So this is the filter boards. These are the And I don't know what else we got. It's a whole massive pile of boards. So this is, I think, a whole bunch of 1616s, and it's pretty rad. We're on our second manufacturing run of boards now, and so while having hardware and stuff to sell is cool, most of the hardware that we sell and ship, I handle on the way out, and having the bootloader stuff done, oh my gosh, is going to make that experience so much better. Because what I can do then is I can go through, and if I need to spend quality time with the kids, bring them down to the shop with me, and we can go through and set up a whole bunch of hardware. Go through and program a whole bunch of boards with the bootloader, and then I know that in my checkout process when I'm ready to ship, I can basically pull all the hardware we're going to ship, set up in the test rig, and just shoot the latest hardware or latest software through, and everything's ready to go, and then send it out its way, instead of having to each time we do it is getting out the programmer devices, connect each piece, go all the way through. It's a very cumbersome kind of process, and now it's I can just have a test rig that's ready to go, throw the file at it, updates everything, hit each processor, and we're ready. So it's really going to make the process of fulfilling orders and stuff like that a lot smoother too, which I'm stoked about that.
Yeah, yeah, and especially like now, Aaron also we can put test code in there and very
Yeah.
quickly change it to the, whatever the latest version is just before it goes out the door. And if I don't know if we come up with some really cool test code or something useful that people might want to, check their own units out. Now it's a simple process to give that guy, give that code to you to kind of mess around with and be able to do whatever. So I don't know. It's exciting to be
Yeah.
able to have that flexibility now where we didn't have it before.
Yeah, and I think that like that's where all the effort and work it takes for us to like get hardware out into people's hands. All of our customers and friends, users, everybody that's got fast hardware has been like kind of part of that inaugural class of people like who know that like, oh, we might have to send a software update, or bootloader's not done, so I might just trade you a board instead because it's easier than sending you a programmer and talking you through it on the phone or something. So everybody's patience has been awesome, and it's really come out as like, I guess at least we've taken it as like support, because it's really like we've made so many friends through this whole process and met so many rad people making cool stuff in pinball from all walks of life as we've kind of gotten this fast thing going over the years. So now going to these shows and stuff like that, it's not trying to convince people that we know how to make hardware or we know how to like create a cool product. It's more to like see our friends and see what cool projects people are working on, or meet people that are working on some fun project that we've never even heard of before. And it's like I'm still shocked by that. That like I try and keep up with all the projects going on out there, and then even to have like even one of our users spring on us like, hey, I'm coming up to your show in June and I'm bringing a new pin you've never seen before. I'm like, what? Like, awesome, So that's kind of our next big show coming up is at the Northwest Pinball Show in Tacoma, Washington, June 3rd through 5th. I believe that's nwpinball.com. It's got all that information. And what we'll be doing there is kind of like what we did at the Pinball Expo in Chicago back in fall. It's basically be able to have different games at different stages of development that different users have been made that we've been working on and stuff, and let people kind of come up and look around, open things up. It's always been kind of fun at these shows because our booth ends up being like a shop. Like it's just a bunch of like soldering irons hanging out, wire running all over. But rather than looking like a mess, people are very curious about it and want to come up and see what's going on, because a lot of people get to go and play pinball at shows but don't get to necessarily like see how it works underneath and go up and ask a question with someone totally willing to answer it. And it was really fun at Chicago, being able to have like, Jack was out there, I'd walk up, he's answering questions about our hardware and stuff and how he uses, or Chris or Mark or Brian and Gabe or yeah, I mean, all, the Mission from Pinball Framework running on stuff. Like it was just kind of everybody getting together going like, look what we're working on right now. And our Northwest Pinball Show is going to be our next experience, or next opportunity to do that. I think that's been pretty fun.
Yeah, I'm looking forward to it.
What else is going on?
Well, one thing I'd like now. So hey guys, if you get some more ideas or features that you need and things like that, or ways that we can make it better, I think it's a lot easier for me now to, like I know everybody wanted that reset thing, so I try to throw that in there at the same time I was doing the bootloader. I made some watchdog enhancements and a few things like that. So boy, you get some other ideas or features that you'd like to see, please let me know. I'm working pretty aggressive on the daughter board, not only just on the interfaces we want, but trying to make something generic so that whatever ideas you have for daughter boards, you can make up your own. So I'm trying to get that whole template on how to do that, and that's one of the things that I want to do here in the next couple of weeks.
Yeah, and I think the other thing that's really kind of cool about like having this bootloader not be such a moving target thing, and like hardware being in stock and stuff, it's really going to let us kind of hone in and dial in all the documentation and stuff like that we've been working through. It's been kind of a living process of Google Docs and things like that users have been using and commenting on. But it's been really, I mean, I've kind of tried to take on that challenge, and it's been something that's been really hard for me to do from the standpoint of like, what is it that we're trying to create? There's that black and white documentation of all the commands and stuff, and the command structure, like there's so much you can do with it. How do you do that in a cool way? And in a cool readable way. And actually, like we came across like Dave showed me like a doc they used at like another job on another project that I'm looking at it going, why didn't I see this like a year ago? And I could have done the same format, because it really did a good job of having a simple description of how certain things work, but lets you get into some of the deeper command options if you need them, but in still a readable document. And so you've got the black and white documentation needs, and then you've got the more, I guess you kind of call it like the cookbook needs, where it's like, I want to make this. How would I make this? And what we plan to do is we've had a lot of requests for kits, and it's one of those things that like, we kind of went back and forth on for a while with the idea that like, a kit, make some bundle or something like that. And what we decided to do was make a kit that was like, here's everything. Here's power supplies, here's connectors, here's pins, like here's a set of boards that'll give you plenty of resources to be able to build a pinball machine. And what we're going to do is use that kit as a kind of walkthrough and make smaller video tutorials and guides and stuff like that. So we'll say like let's switch over to this other camera real quick. So like from here we might do a section that we're going to focus just on like the power supply section. So it might be like, okay, tonight, and try and break it into stuff you might be able to do in an evening or a couple evenings or a weekend. We're going to say, okay, we're going to set up your power supplies. So you've got your high voltage supply and your 12 5-volt supply and your filter board. We're just going to take care of getting that right up right now, and show you how to, the things you need to do to troubleshoot. Test your voltages, make sure your hardware enable, on the filter board works. And part of the reason that we want to do that is to make sure that like not just from the standpoint of like show these very simple steps, but what we can do as being able to support users is say, start from what like we've kind of guided here, so we know that at least you've gone through the tutorial or watched the video, so you know that we're talking to you, making assumptions that you've seen that set of instructions or something. Because what I've also learned, or we've both learned, is like everybody comes into this with really different experience. Like somebody might be coming, might come in talking huge game about like, how electronics work and how they build boards and all that stuff, but working with power supplies and stuff like that was something that was always solved for them before they got into the project. So they're going, how do I hook power up? And I'm going, dude, you're designing hardware. Like, how do you not know how to deal with power? Or from the other standpoint, people who work on games all the time, who know how to work with existing infrastructure, but starting from scratch, it might be kind of hard to just start into it. So really trying to chip it down into, let's set up your power supplies, check. Now we're going to hook up your controller and do some RGB LED commands, or read some switch inputs, or send some simple driver commands. Just turn it into these small chunks. Where again, if you know what you're doing and you can skip ahead from all that stuff, totally fine. But I think what that gives us is kind of these building blocks that says, if you follow along with this, we know where you got to at this point, and we made sure that you have used your multimeter to test the voltage, like test points on a board, just stuff that lets us kind of get everybody on the same page as far as capabilities and experience real quick. And then we can focus on the more complex things, like maybe you're trying to do some cool things with magnets and it's not acting the way that you want. If we know you've gone through these steps and that your hardware's all hooked up right, now we can focus on that specific thing and not wonder, do you have a crappy power supply, or like was it wired wrong or something. So it's a way just to kind of prepare for the best experience for us to kind of help, because what we can't do is like dive into every single project and spend a weekend getting familiar with every single wiring connection and stuff like that that you've done on your board or your play field or something. But we can just kind of do a quick primer that says, have you gone through these steps? Yeah, I've done this, I'm using this power supply. Now we can get into that. And that's something that like, that's where we want to help. We want to see like these cool ideas and stuff like that like come to life. But I think that's kind of the challenge now, is to go through and get all that stuff into something that can be consumable by new users or experienced users that want to really make sure they're using the fast hardware right. But back to the bundles for a second, it's like it was something that I was kind of resistant to initially, because it's like, well, you should know how to go pick up and grab all these supplies all over the place. But it really came out of a lot of our international customers asking, saying, I get taxed every time I get something sent to me. Can you just put it all in one box and send it to me? Give me the number of connectors I need, the pins I need, all that kind of stuff. So that's where like the bundle offerings and stuff like that. It's not meant to be like, here's this big like the ideal package for you. It's just, this is something that might cover most of your needs and give you a good starting point. Otherwise, you can a la carte pick and choose all the different options and build your own kit. So yeah. Ramble.
So do we have any other questions? Let's see.
So apparently there's a quiz afterwards. And okay, so Gabe's talking about how do you get your kids to program the boards for you? Gabe, did you get to meet my kids when you were out at Northwest show last year? Like, they're all about this. Like my oldest son, he's the one that's learning Unity right now, and I'm learning with him to spend father-son time on that. But my middle son Henry is he's my go-to guy when it's like, hey, I got to sort all these parts, or hey, solder this for me, or here, hold this. I can hold up a board and be like, hey, help me solder this, and he'll know where to feed the solder to me as I'm moving down the pins or something.
Wait, just the other day he fixed a toy. You guys solder? Yeah, he just
dude, that was crazy. So, quick tangent story.
For Stella age.
Yeah. So he just turned 9. 2007. Yeah, it's 16 now. Okay, so he's 9. So he's been doing that for a couple of years now. So he has his own soldering irons and everything. So Dave and I are doing a video chat, like talking about probably, yay, the bootloader's done or something. And Henry comes in to be like, hey, like I had this toy that one of those like kits you build with all your electronics and stuff on there. And he basically like takes the, it wasn't, one of the things wasn't working right. He's like, yeah, I just resoldered the motor on, the connection broke. I'm like, yeah, right, whatever, I'm talking to Dave. And Dave's like, wait, what? Your kid just fixed his own toy? Like, that's awesome. So I think that it's really fun to kind of have that environment, around all the time. But my youngest son is like, I don't know, 6. He really could care less about the electronics and stuff right now. He's just playing pinball. Like, he sees some prototype or some simulated game that we're working on, and he just wants to, move over, let me try that, let me see what that shot does, on and on. Dude, it's totally a proud moment. It's totally awesome. So I think that, like, back to getting them to program it, they would absolutely be all over that if well, I guess they could now. I mean, the bootloader stuff makes it super simple.
Oh, yeah.
I mean, they could do it. Henry was down here testing LEDs for me the other day.
Looks like Gabe had a question here. He was, what's the board with the RJ45 ports next to the Nano? So here, let's go out with the camera there.
Here, grab that one right there.
Okay, so
you're talking about the green one here?
Yeah, I would imagine that's the one. So that's kind of like, we kind of call that our bulkhead connector, do we not?
Yeah, it's an interchange kind of thing. Like, it's basically set up so that, like, you could have that on your play field if, say, your controller was going to be, in the back box or something. So it's designed so that you could have, a quick disconnect. So basically, you can send all your power. So right now, it's not really doing anything. Like, we have a power connector right here. So this is taking your high voltage. I think we're sending 5. Currently in this one, it's 5 volts. The green is high voltage, red is 5 volts, and then ground. So we'd be sending that into the playfield. So there'd be an out connector here going to all the stuff that's on your playfield. And then our network, so it's basically coming out of the controller, and this is just a pass through, so you could disconnect it in one place. So if I was taking my playfield off, I could disconnect this one here and these two, and then pull my playfield out, put it back in my rotisserie or something.
Yeah, so that's basically all it is. So really quick way to disconnect everything for your playfield, and I don't know. We just kind of did it as a quick thing to see if it was useful, and we don't know if we'll ever per se manufacture that, but we'll probably do something like a kit. Just let you solder the connectors on if you're interested in having that, because
you just throw something to throw with the filter board or something.
I mean, there's nothing on it except for connectors. So.
And I think that a lot of what I experiment with, I take my playfields in and out on this frame system that I have. So like being able to have one cabinet that I develop on and not have to have a cabinet for each game, or rotisseries just drive me crazy, and I'm always tripping over them and stuff. So I like kind of that, take them in and out setup.
All right, go to a different screen here. My arm's getting tired holding this camera.
No, Dave, keep going. Dave's face. Okay, is there a way of wait, hold on. Problem moments, more boards, lighting, things happening. So modularizing the power. Yeah, so it's basically just trying to make it easy to disconnect and move things around and stuff. So Gabe said yes. Cool. We are using. Wait, who's that? Is that Jimmy? Like the screen, I can't read some of these like names and stuff on here come through as like neon greens. Yeah, Wizard Blocks. Wizard Blocks is cool. That's a cool project. That actually just came up earlier today. We're talking about ramps and stuff like that. Dude, what's up, man? I'm glad you stopped by. My dad was here. We were talking about ramps and stuff earlier, and you came up. It's like, oh, that guy was super nice. Like, so, we talked about you. But yeah, so we're trying to find those little ways to kind of make the game design process a little more elegant and stuff too. Because what's nice is like if we can tell you like here's a reference design for a playfield. Like here's all the components that are on there, and here's how we would wire them up to make sure that everything was totally sound and ready to go and like stable as possible. And that way you can look at that and go, okay, that game's like mine except for this and this. But it's kind of, that's how I learned a lot of things too, was finding, I know what this does, I know how this works, and this is what I would need to change, and if I follow the same guidance, it should work out. So,
so I got JP saying,
that's Jack.
Okay.
You know that?
Yep, I didn't know that. So absolutely, Jack. Yeah, I'd love to take a look at it.
Gonna do that right now.
So
now you start your stream. Stream it back to us. Dave was asking like, why can't we do this like in real time, like a Google Hangout? And I was like, man, can you imagine like everybody in real time all jump? It would be mad.
It would be mad, but it would be cool.
It would be cool.
Yeah.
That's Dave and I and many of the fast users and stuff like that. We've spent a lot of years and stuff like that just hanging out on Google Hangouts and stuff. And my wife used to come out and hear me like kind of laughing and joking around, and she'd watch. And I look at my computer screen and I'm watching Dave doing board layouts. We're just chatting, like watching layouts. And I used to joke it was kind of like the most boring TV in the world, but it's super fun seeing things come to life. So that stream stuff is like super fun.
See, it's been about 6 months or more since we've done that.
Yeah,
that
sat down
shows you how long.
Like work on just a board.
I'm so glad I'm done with software for a little while. I'm telling you.
Yeah, like it's always been like a lot of fun to like come up with some idea and then start working out real quick. What's a good solution for it? And it was always funny, like I'd have like an idea about like how I want it all fit together and everything lined up. And it was like, so you're telling me how big my PCB gets to be before we even make the product? I'm like, just trust me, it'll look really cool. Like, okay. So we do have fun. Let's answer more questions. Okay, Dave, Power Spies.
We're almost out of them.
I think we're caught up there. Let's see. I don't know. We turn the cameras a little bit. Show you kind of what else we're in. So that big screen in the background there. Like we spend a lot of the afternoon. We've got an arcade downstairs, and we've been trying to get like a game arcade set up in general in the town we live. I live in down here in Gig Harbor, and we spent today earlier like getting the machines dialed in, making sure they had coin mechs and stuff as we a little closer to actually be able to open that arcade up. But one of the cool things we wanted to have by having that arcade was have a place where like maybe maybe you're working on a new original pinball game. We can have that in this kind of safe. What's up, Roy?
Thanks, Roy.
We can have that game set up. So we had Tattoo Mystique that Brian Cox made, and we had that in the downstairs arcade. And we weren't open to the public yet, but we had friends coming by and stuff all the time. It can be in an environment where it's not like it's off in some bar and you hope the bartender knows how to take care of it or something. We do have a karaoke bar across the hall, but it's someplace that we're like we're around and we can let people come play it and see like how things work, or knowing how those games work if we need to go boot up some software or do some resets or something. But it's kind of like a safe environment to kind of road test some of these things. Okay, Mark. Hey, Mark. When is your coin door daughter board coming? So that's one of the ones that's like come up as like as a cool option to have, where basically like you can have a daughter board interface set up to match the coin door interfaces that you have on your pinball machines, but also be able to put in like some NVRAM or something like that to make sure that like you don't lose your audits and credits and stuff like that. So we can have like some counts that are actually done that your software can query, and doesn't get lost if a log file gets destroyed or something.
That would be a good discussion topic on what people would need for that, because I tried to do that a little bit with the first board in our system. The first 8 switches, wherever they're located, are global to every single driver board. Mm-hmm. So the idea was that board could be down there, and then the flipper buttons if you wanted to, and all of that could go out and be broadcast to all the boards in very fast fashion. So there is the possibility of putting some board down there, even if it was like an 0804. If you needed more switches, maybe put a daughter board in to give you another 16 switches or something. But yeah, I mean, we need to talk about like how important are coin meters these days, and some of the other I/O that was down there. Right. Most of it's just switches. There are sometimes like lights for the start button, and do people want an RGB LED down there? Because it is interesting on where you're gonna how you're gonna wire those LEDs like way down in there. If it was just a standard lamp and we had a few lamp drivers, anyway, what would that look like? What's needed on a daughter board or a
well, I think the
front door board.
Yeah, and I think that's when we can start to kind of throw, now that we're not like, working on all the stuff under the hood all the time, but you start to throw up like, concept pieces. Like, hey, what if we had an interface like this? Like, this we think this might be a good idea. What did we miss? Or what pieces could we add to this that would make this better? And I think that's what's going to be. That's really us getting back to what we enjoy most is like creating cool hardware that lets you make cool pinball. But Dave threw out a topic that like I think we can elaborate on just a little bit. He's talking about the priority 8 switches. So the way that our hardware works is like it's basically configured so that if a switch is triggered, it's going to fire the driver on the board itself and then tell the controlling system it happened. And that's done to like keep latency to a non-issue. But having switch inputs on other boards, controlling drivers on other boards, that takes a little more orchestration to keep that all high priority and zero latency. And so that's where that concept of that priority packet came in. So it's like, what's that, like the first thing after the watchdog going around or something like that?
Yeah, it's really fast, and it's like it's just a byte that goes out as part of the protocol. So all of the nodes are touched very quickly, but obviously the payload each time, if we were send every switch to every single board, then there's going to be some latencies. It might add a millisecond or two on there, and it's like the whole thing that we want it to be is very deterministic. So anything that kind of goes against being deterministic is kind of like it's not what the goal was, and it's like it's not something I can control because it was either all or nothing. Right. So it was a compromise to sit there and do the first 8 switches to broadcast those all the time, and I was really happy with it's pretty minimal latency. I don't think people would ever notice it, but yeah, I mean we're allowing now up to 256 switches, so you can imagine every single time if I have to give all 256 switches to every single node board, then there's a lot of data that's unnecessary to broadcast.
Well, I think that's like a good point as far as like originally it was like that doesn't fit into our spec as like how we're designing the system, but that one really came out of like okay, we started building some games with this, and like it would be nice if we didn't have to run all these wires all over the place. If we could create a little more elegant interface where maybe we just drop a couple RJ45 cables into the cabinet that go to this board up in the front that are plugged into your switches, your coin doors, your shaker motors or whatever, and then back up to the playfield. But your switches, your flippers say being fired by drivers on one of your 3208s, but your switch buttons being pressed on the cabinet going through maybe an 0804. That priority packet, basically every board treats it like it's a local command, like it's a local switch. So it's one of those things that we can say, these are some of the concepts and stuff that we can advise people to use that they can choose to include in their game or not. And that one really came out of like using the system for a while and saying this one's worth the effort to try and figure out. So, and then Mark says, don't forget the kitchen sink. What about the bathtub? I don't know if you saw like Mike Swizzlefish on here printed Mark some really cool toys for his Nightmare Before Christmas game. The bathtub piece and then the whirlpool in the back. He's got pictures of that up on like Inside and Facebook and stuff like that too. Just a really great example of like great pinball people working with each other from all different countries and all around the world. There's a lot of really cool people that are making some really cool pinball stuff. Well, yeah, did you got to see the videos, right? Like, I mean, it was kind of, as an observer watching the whole process. Like, I was even showing the kids that, like, my son Henry, who does 3D printing stuff, being able to say like, my friend Mike, who they all know as this guy that does rad game stuff as his job, and our friend Mark up in Canada, who is making a really cool pinball machine. I got to show them the two people working together and see it actually like work in a video. So they were just so impressed, like that. I think it was more impressed that they mailed it all the way to Canada, maybe, because like the concept of like sharing data and projects online isn't so impressive, but the idea that like, wow, they sent it all the way to Canada for some reason was kind of cool. So yeah, I got through customs and stuff like that. Okay. I don't know, what else were we talking about? We've been rambling. I thought this would be like a really quick one, and we just started like telling stories.
We could always go back to version 0.99. I mean.
Okay, yeah, let's do that real quick, just for people who just joined us. Okay,
there we go.
So we're gonna switch over here real quick and revert back. Okay, so I'm gonna make sure I'm on the right processor here. Okay, so we're on net processor 1. Okay.
Yep.
So you see that this shows us that we're looking at firmware version 1.0. So I'm going to go again to the send text file command in my terminal emulator. I'm sending it the code for 0.99, and it's on its way. Showing progress, copy complete. So what's it doing?
And so now, and here we go to the cameras now and kind of show all of the nodes starting to, let's see, we're on this one right now. That was the first 1616 board. In just a second, it should finish programming that one. Now it's moving down to the...
and again, this lighting effect that's doing is showing that that's the one that's currently being worked on. All the others are doing a single LED strobe, which just shows that, like, hey, I'm not happy. Like, I'm just, hold on.
Yeah, it's kind of like a watchdog timeout. Since no one else is getting data right now except for the one board, everyone else is kind of like pissed, like, damn it, where's my data? And so anyway, so now we've probably moved up here. That's the one I couldn't see last time because the cable got in the way.
Like, what's happening? Oh, that black cable covering the LEDs that makes it look like it's not working?
Yes. So anyway, it takes, I don't know, it's a couple of minutes to, update, but I don't think we'll be doing this, very often. Maybe, what, I don't know. Depends on how many toys and stuff we add, I guess. So
well, yeah, I mean, that's one of the things that, like, the bootloader really gives us the ability to do changes and stuff like that. It's not like, we have a huge list of things we're going to do, but as soon as, like, we get that idle time and take a breath, like, we're going to make a couple new boards and a couple new features, a couple new toy building parts or something like that, and then we'll find out, okay, we need to add a new feature that lets that stuff really perform the way that we want it to in the system. And again, like, the idea is that, like, you don't have to update to that latest version of your game run, but obviously you won't be able to take advantage of those features and stuff too. So there's a lot of things that we want to be able to do, even to make the protocol language and stuff like that have more commands that you can use as software designers to, like, query the system. And that's one of the things we really like. Okay, so everybody's happy now.
So everyone, you kind of see now that's their standard, linked plus status flashing going on there. So now if Aaron goes back to the terminal now and we do the configuration now. Yeah, I just dropped something here. What is that? So a foot fell off your camera.
Don't worry about it.
Okay.
Okay, so now we'll do the IDE command.
And so we can kind of see now the version of the nano controller is at 0.99. If we do go look at the nodes now with the CN command, and now we'll see they're all back to 0.99. So the nice thing is if we ever release a version of software and for whatever reason you don't like it, doesn't work, whatever else, it's pretty easy. A couple of minutes you can go right back to the old version. So
and again, that's where we got to, like, keep in mind that, like, somebody may have worked, like, all weekend on their game, and it's totally cool, and they've got family coming over for some big birthday party or something, and they want to show off their game, but they also heard that the Fast Guys released some new firmware and stuff. They want to try that out, and for whatever reason it's causing a problem in their game. We want to make sure that it was just part of the process to naturally be able to just roll back to the version you had before, and not have to slow down your game development process just because we had something that was new and creative and stuff. And I think that's David said earlier on too, like, we had this, like, dream list of what we thought the bootloader experience needed to be. If it was the bare minimum of update code, don't touch anything while it's happening, don't mess up your computer while it's happening, like, it's just the bare minimum, that would have worked. But we really want to make sure that it was, like, something that everybody could use it in real human use cases and be able to move in and out of versions and stuff like that as needed and stuff. So again, like, being able to introduce new commands into the system that let software designers query our boards. How many boards are in the system? Last time I queried, I had 4 0804s, and next time I run my software, I queried it and I had 3, and I want to throw a message because that's not right. Just things that we can try and expose about the hardware so that the software writing experience can be as slick as possible. That's really what the protocol language on the boards is all about. Like, you don't have to load a software library just to talk to our hardware. All you'll end up doing is installing the FTDI virtual COM port driver that comes, like, installed now on Windows 10 and stuff like that now has it, or I think Linux has it and stuff too. So that lets you get our boards and talking to your system really simply without having to have a lot of complex drivers that are on their own really important and stuff. So yeah.
Let's see if any more questions came in, and I guess we could.
So Jimmy says that's slick, and I agree. And this is cheesy, but I don't care. Like, I think that it's a lot of fun when you look Dave's face. I think it's a lot of fun, like, running this bootloader and stuff like that. Like, you know, I set up this whole test rig, the one that we have over here, right there, as something for me to test. We had a customer who had a weird situation where like having more than 8 boards was like not happy, and there was like something in code where we limited it to 8 because we didn't have any more, and it was just extra wasted data and stuff like
and
that.
And I think I do it. It's like I'm like 9 boards. I figured no one would ever have 9 boards, and I'm like 9 boards, and I knew I put that in there as an artificial like max limit, and so that's what it was. At the 9th board, it's like the network just did not know how to talk to that last board. It thought something was messed up. So,
but I mean, it was the kind of thing that like it was like, oh, you know what? I did ship a whole bunch of nanos to somebody. So we had a customer who bought a whole bunch of nanos because they didn't know what their game was going to be like. So it was like a whole box of these that you can mix and match to any way that you like. It's kind of like a way to prototype your game. And then if you were going to commercially release that game or build a handful of them, you wouldn't do it with 8 nano boards. You'd combine those and do maybe a couple 32.8s and a 16.16 and one 0804 or something. But what was interesting too, so part of the reason I built this board, this is a woe is me story, but I still think it's funny. Like, I built this board up because we had a situation where like some customers' boards were like freaking out. Like they could get them to like erase themselves, turning the game on and off and stuff. And I'm like, what the heck? Like Dave could not recreate that process, and it was something that like was just messing with me. And so like what it turned out to be was like in my programming environment, like I'd set up a new Windows install and hadn't gone back and set some certain default settings for the fuses that you write when you program the part, and it was basically the one that controlled when it powered up, what its power up sequence was.
Yeah, like a brownout detect. It's something that the part has internal, like some of the voltages at which it's going to do some things, and when those voltages do occur, is it going to reset? Is it going to do an interrupt? Or what's the behavior when those things happen? So
the problem is like hearing people's boards erasing was like, what? Like it was freaking me out. And so Dave's like head down on like the bootloaders. Like, dude, I can't get it to be a problem. Ask more questions. Get me more information. So I built this whole test setup here. So like come back over here. So this setup, it had more than 8, which is we needed to figure out the problem with. The one customer had a whole bunch of nanos, but I needed to be able to make my boards erase themselves like on command. And our friend Eli was up here for another reason, and we're sitting here. I'm like, okay, power on, power off, power on, power off. Boom, this one goes down. Power off. This one goes down. I'm just on off, on off, on off. This one goes down. It's like, oh my God, we got it. So I update those boards, do it again. Bam, 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 they're gone. So we went through, changed those fuse settings to what they were supposed to be, and couldn't get it to erase anything ever again. And in fact, I had Eli come up and like, okay, here, you turn it on and off so that we're not babying it or gaming it or anything like that. So after that night, Dave's like, hey, could I take that home? So that whole test board there, like, and I'm like, yeah, I mean, it works great. Like, put it in the closet when you're not using it, but when you're focused on it, like, just switch back real quick. There's room for your laptop right here, you got everything right here. So it's your little, dinner tray of like everything you need to work on. So anyways, like, it's one of those things that like, I love the bootloader because I can't mess that up anymore. Like I can't like send out a few settings because the bootloader does that for me. It's not remember these settings all around. It goes, I'm programming this part. You need to set all these settings for these processors a certain distinctive way. And what this also does, I mean, looking into the future, like say we find a new processor that we think is super great and we want to work with it, we can put those things into our product and the user doesn't have to worry about it. The protocol language will work exactly the way that it's supposed to, and we'll have the firmware that's running under the hood work with that new processor in a way that takes care of it the way that it should. But the bootloader will go through and know that it's a 16.16 version 4 runs the Atmel like D27 or something like that doesn't exist yet. And you don't even need to worry about that. So these are those things that we try to look at in the future to make sure that creating new versions of boards that you might drop into your system. If you have an old 16.16 and a new 16.16 and you go to update them, know that we're paying attention to that stuff and looking to the future. So at the same time, like letting like the game designers focus on being designers and programmers being programmers and stuff. We want to make the hardware part like the kind of the boring part like I think it's cool. So I'm not.
Well, I think it's cool too. So
it's the part that when you're making your game, you don't want to be thinking about the hardware that's running. You just want it to work. and we want to make sure that like the hardware part of it is rock solid and flexible and all that kind of stuff. And I don't know, it's like we were saying earlier, like being able to go back to hardware now and just focus on hardware. It's like you got the chores done, it's time to go play again.
I still felt guilty though. I'm telling you, Aaron put all his work into making this board. I just saw it one time, you know, when he's doing that test, like, Aaron, I really need that. And I'm telling you, it probably would have taken me another 3 weeks on the bootloader had I not had this. It was just a great test. My boards were always just floating on my desk. They'd touch each other, short out every now and then.
Yeah.
So when I had problems, I didn't know whether it was me or my setup. So this has been great.
Well, I think that just kind of fits with like my normal process and like figure things out is like reduce all the questions you can. Like, yeah, I mean that's why like before I step into like a big project I'm working on, it's like I'll clean the office up. You know, it makes it hard to find my tools for a few minutes because they're in a drawer where they should be. But you get as much as you can like organized and set up so that you're not wondering, is that board plugged in right or does it actually have power? So this test setup, like I'll confess to you right now on this stream that like I totally set it up so you would take it home. So don't feel like you stole it from me. I just know that like
it helped a lot
for you to be able to sit down and just focus on just the software you needed to, knowing that all the stuff worked out. Like I think it was like totally worth it, and it's a good tool too. I mean,
yeah, it is. It's great. I mean, it's my new test board for testing all the code res, and I mean it's been fantastic.
And so what I plan to do with I'm going to build up another one, but I'm going to do it in video chunks where we'll go through and set up the power supply. Basically I'm going to set up, the process is going to go like this. I'm going to have a kit, just like you could buy from the website. I'm going to open it up and we're going to be like, hey, look at all this fun stuff in here. And set up the power supplies and go step by step. First chunk, we're going to take care of power supplies. Next chunk, we're going to go through and get our controllers talking to our other boards. And then we'll go through some other test cases and stuff. So I kind of saved that task for making sure that it all looked good when, or the exercise of putting it together was something that other people could witness and see how that goes. And stuff
no one's responding for a while. I think we put everyone to sleep or something now. So
they're like, all right, pinball. I've heard all the new stuff. Okay, now they're just rambling.
Yeah.
All right. Well, I think we'll probably call it for now, unless we get another question in like the next 2 minutes. But this is just kind of a fun update for us. Saying we got this bootloader thing rocking, and now we can get back to full. Bootloader is sexy. Thank you, Roy. But being able to get back to like the hardware fun part, because I mean, there's nothing that like I think Dave and I find more satisfying than to see like pictures and stuff like that users post or send to us, like in our Slack user group or something like that, to be able to see the potential of what people can build, because that's the part that like that's what has us doing all this stuff. Like it's a blast. San Diego. Okay, so I know our next California trip will be California Extreme. And you're coming up for that, right? That's what, in July this year, I think? We've got rooms, and we'll probably go crash on Brian's couch again and stuff. Oh, thanks, Mark. The kits are going to go up. We're moving to a new web store right now. We've been getting so many international orders that the Squarespace store that we're using currently doesn't play nicely with international shipping and orders and stuff. So I have to go through and set up like, they email me what they want. I create a PayPal invoice, send them. It's just a pain. So we're changing over to like a Shopify setup that should make all that a lot easier to do. So that's where the kits and stuff like that will go in. But yeah, all the boards and stuff like that are long time available on the website. And yeah, and then okay, cool. Yeah, so we'll see it at CAX for sure. And I think that I don't know if Brian's on right now, but Brian Madden lives down in San Francisco there. And we did a really fun thing. It was like, because California Extreme is just Saturday and Sunday, and so we got down there I think Thursday or something, and we had we just kind of had like a family dinner at Brian's house, and Brian's brother cooked a bunch of food for us, and Mark and David were in town, and they came out and hung out. So it was just like, it's kind of this tradition that we started. And then we were in Chicago, we all went out to dinner and stuff too, and it's just kind of a fun chance to all sit around, break bread together, bring your families out, and see all your crazy pinball friends and stuff. So I think that's what we're going to plan on doing, something to that effect down at California Extreme and stuff too. So yeah, that's something that if that does come together, we'll probably tell more people about it.
Roy, are you making it to the Northwest show?
Come on, Roy. You want to come and hang out.
Yeah.
I think you reserve rooms with the option if it ends up working out with the schedule. So, yeah, I think it's gonna be fun. Like we said before at the Northwest show, we're just gonna have the same booth, building, working on projects. Probably do some live building so people can see actually how stuff comes together. And yeah, So I know that like I know Roy, you'd be a lot of fun to having that. And I don't know if everybody knows like in early days when Roy still lived up here in the Northwest, he lived between Dave and I. So like we used to have late night like board building, like code writing, like get-togethers at Roy's because it cut my drive time down significantly. Leaving at like 4 or 5 in the morning and have like my rule was I had to get home before my kids woke up because I had to answer questions like where were you? But if I can get in, before 6:37, like I was home free. So
and Roy's cats absolutely love me, although I'm deathly allergic to them. So it was great. I got the most love from the cats, and it's like,
aw,
but still,
buddy.
Yeah. I do miss him, Roy.
Yeah, dude, and dim sum and
we haven't been there since. We need to go there and like call Roy when we're there. Hey, Roy, we're doing that good dim sum.
Yeah. Well, cool. Yeah, I mean, get the time off. If you need me to call and fake a doctor's notice or something like that for you, I'm not above that. I'd love to get you to hang out. Yeah, Buddy loves Dave. Buddy also will find any chance he can to get under my foot. Like I mean, it was like a cat the same color as the carpet, and I would not see him forever, and then I decided to stand up, and I stand up right on him. And you know what? I think that's just his thing, but I think he probably misses us too. Okay. So I think we've been rambling for like an hour now. So I think we're gonna call it. And Dave's got to get home, and we got to clean up around here. We got the arcade and stuff like that all just about ready to open downstairs, and that'll be maybe in the next couple weeks or so. Got a couple games that we're bringing in to kind of finish out the lineup. But I tell you, like people come by, it's like we've streamed it before, but it's like a fishbowl down there, a big window across the halls, like a restaurant and all these other shops and stuff. And I had a couple ladies stop by today, just going, we love pinball. Like, when's this going to open?
And it's weird. They didn't even knock. They just like opened the door right up. Just came in like, hello, we're working here.
Well, I think that's the thing that people just love is the nostalgia and the pinball. So I think it's going to be a lot of fun to have that open. We had my son Henry's birthday party in here on last Saturday, and we heard from some of the parents. They were asking like, one kid was like going on and on about Burger Time, and the mom like called my wife going, "What is Burger Time, and why does my son keep going on and on about it?" So you got hooked on the Burger Time game down there, but all the other kids and stuff like that just had a blast with the pinball stuff. So, anyways, all right. Thanks so much for hanging out and listening to us ramble. And we'll check in more often now that we're not head down and beating our heads against the wall on a bootloader.
Yeah.
All right. Good night, guys.
Night.
See ya.